I'm David Hill, the Corvette Chief Engineer, and on behalf of everyone here at Team Corvette Engineering and at Chevrolet, I'd like to thank you for choosing Corvette and assure you of our commitment to your satisfaction. You know, I've been with General Motors for over 30 years, and the last 2.5 with Corvette, and in that time I've had the opportunity to meet with many Corvette owners, and I've done my best to listen carefully. When you get behind the wheel or open the throttle on your new Corvette, I hope you see, feel, and hear the influence of your fellow owners, because I assure you it's in there. So please accept our best wishes for years of driving enjoyment in your new Corvette. There's nothing else quite like it on the road. And thank you again for choosing Corvette.
In this video, we'll explore the many facets of the Corvette ownership experience. First, in performance review, Assistant Corvette Chief Engineer John Heinrichsey and NASCAR driver Jeff Gordon offer an up-close look at the performance design and capabilities of your Corvette. Next, members of the Corvette engineering team review the major technical highlights for 1996. It's followed by feature operation, which provides step-by-step instructions on the use of key features and controls, and Corvette Care, which offers valuable information that will help you keep your Corvette looking good for years to come. You'll also go inside the Corvette assembly plant in Bowling Green, Kentucky, to see how the latest advances in manufacturing technology, craftsmanship, and personal commitment work in harmony to produce Corvette. And finally, you'll ride along with members of the Corvette team as they evaluate pre-production models in an audit drive that's one of the many steps that demonstrate the commitment to quality behind your Corvette.
To win races, you need both power and the ability to control it.
The same is true in designing a great performance car like Corvette. I'm John Heinrichsey, the Assistant Chief Engineer for the 1996 Corvette, and I also race Corvettes professionally in the SCCA World Challenge Series.
I'm Jeff Gordon. I drive the DuPont Chevrolet Monte Carlo in the NASCAR Winston Cup Series. And like a lot of people, I've been a Corvette enthusiast for as long as I can remember.
When you spend as much time behind the wheel as we do, you develop an appreciation for what makes a great performance car.
In the next few minutes, we'll show you how Corvette's powertrain, suspension, and total design work together to create a performance package that is like nothing else on the road.
Most Corvettes we build will never be driven on a racetrack, but the racetrack will always be a part of every Corvette's soul. So we engineer the Corvette to perform under extreme conditions. That way we know it will live up to your expectations on the street.
V8 power has been a Corvette trademark since the first one was put in the 1955 model. From then on, Corvettes and V8 power have been an American tradition. For 1996, 2 V8 engines are available in Corvette. Both are the latest generations of the small block V8 for Chevrolet. In fact, there are 2 distinct power team combinations in Corvette this year. The LT1 V8 is mated with a 4-speed automatic transmission. It generates 300 horsepower and 340 foot-pounds of torque. The torque band is wide and flat. It's tuned this way so the engine will deliver a consistent level of responsiveness both in the low and high end of operation.
The new LT4 delivers an added level of excitement with 330 horsepower and 340 foot-pounds of torque. It's teamed exclusively with the 6-speed manual transmission, and we've tuned the LT4 to take advantage of the transmission's range. It generates its peak horsepower at 5,800 RPM and red lines at 6,300. We're also able to increase the compression ratio to 10.8 to 1.
But none of these numbers really mean a lot until you get behind the wheel and you press your foot on the accelerator, and then you really start to feel it in your gut. With so many of the sport cars today going to the smaller turbocharged engines from both engineer and a driver, John, why is it so important for the Corvette to have the V8 engine?
Well, Jeff, I believe that it's the predictable throttle response that you get out of the Corvette's big V8 engine. When your foot asks for just a little bit more torque, that's what you get, is a little bit more torque. If you want more, you get more, but you get it very predictably.
And do you think that because of the heritage of the Corvette, that's why the V8 has been in there for so long?
Well, the instant and predictable throttle response that the big V8 engines have given Corvette for the last 40 years is what our owners and drivers have come to experience and come to love. So I think that's a real important part of it.
And for the everyday Corvette owner, you know, what does that V8 engine really have to offer for them?
Well, the wide power range that the V8 engine has in the Corvette really makes it very predictable and puts the driver in control for things like passing maneuvers on two-lane roads where you really don't have very much room, or accelerating in slippery conditions like wet roads where you really need to stay in control. That's a particularly difficult maneuver for the small turbocharged engines because they have inherent turbo lag and you just don't know how much torque is coming and when.
Power alone doesn't make a performance car. The specially built racing engine in my NASCAR Monte Carlo, which is also based on the small block V8, generates about 700 horsepower. But if the car is pushing or if it's loose, it's hard to control. And all the horsepower in the world isn't going to change that. That's why we spend hours setting up our car to handle each and every racetrack.
Now, you can't go out to your garage each morning and set your suspension for the kind of driving you'll be doing that day. Even if you could, there are so many different types of roads and driving conditions, you'd probably give up in frustration. So we've helped do it for you. All Corvettes are tuned to deliver a tight and responsive ride, the kind you expect from a world-class sports car. Using this miniature camera, we can show you the components of the suspension system. They include double wishbone control arms at the front wheels, gas-charged shock absorbers at all four corners, front and rear stabilizer bars, and composite monoleaf springs that run laterally across the vehicle in both front and back.
Your tires also play a very important role in how well you can control the car. On almost all Corvettes, the wheels and tires in the back are larger than those in front. This is another example of how the Corvette team has engineered this car to make the best use of its performance capability. The larger tires in the back maximize traction, while the smaller tires in front help contribute to better steering and handling. The tires are Goodyear Eagle GSC radials. They have an asymmetrical tread pattern that puts more rubber towards the outside of the car. This helps enhance traction while cornering as the weight of the car shifts to the outside.
One of the things our team has been most proud of in recent years is the ongoing development of Corvette's suspension. Our mission has been to maintain Corvette's outstanding handling characteristics and at the same time make it a more pleasing and comfortable car you can feel good about driving every day. And in 1996, I think we've made our biggest stride yet.
What John is talking about is the new selective real-time damping system that's now available on Corvette. It's a sophisticated setup that utilizes sensors at each corner of the vehicle and a state-of-the-art control module that can readjust the suspension every 10 milliseconds. How fast is 10 milliseconds? Well, think of it like this. If your Corvette is traveling 60 miles per hour, the suspension can be readjusted in less than a foot of road travel. Take it from a guy who knows fast. That's fast.
Using sophisticated motion sensors at each wheel, RTD can calculate several different body motions. Those body motions are heave, which is the up and down motion of the body you experience when you drive over a swell in the road or a railroad crossing, roll, or the side-to-side motion you get when you steer the vehicle, dive, which is the nose-down motion you get during hard braking, and pitch, which is the nose-up motion you get during sudden acceleration. This data is continually being sent to the control module, and based on the way we programmed RTD, the system controls the damping of the shock absorbers, firming up the ride when it's necessary, and keeping it softer during normal operation. This computerized simulation based on actual test data shows the difference in the body movement between a car that is equipped with RTD and one that is not.
As the driver, you can adjust the sensitivity of the system by using the control switch on the center console to choose Touring, Sport, or Performance. In the Touring mode, the system is set for a softer ride, and it takes a higher degree of speed and body motion to activate the firm damping setting. When you choose Sport, you're telling the control module to kick in the firmer setting earlier, and in the Performance mode, the system is locked on the firm setting.
RTD is another example of how Corvette is a technology frontrunner for General Motors and Chevrolet. If you think back, we first introduced standard four-wheel anti-lock brakes on Corvette in 1986. The system helps prevent the wheels from locking under hard braking so you can maintain steering control. Today, anti-lock brakes are either standard or available on every Chevrolet passenger car.
We've talked a lot so far about how Corvette's systems are designed to help maximize control of the vehicle. One of the most important features that helps you as the driver maintain control of the car is the standard acceleration slip regulation system. ASR utilizes brake intervention, throttle relaxation, and engine spark retard to help Corvette make the best use of available traction. This testing scene on a split coefficient surface dramatically shows the benefit of ASR. The driver who is using ASR is able to move forward and gain momentum. On the other car, ASR is turned off. You can see that he's going nowhere fast.
Finally, we come to the most important element of all, you, the driver. Corvette's cockpit is designed around the driver. The gauges are all easy to read at a glance, and all the controls are within a short, comfortable reach. Your concentration should always be on the road ahead and the traffic around you. The steering wheel is easy to grip and comfortable to hold, and the seats help keep you in position with excellent side, back, and thigh support. Normally, the lap belt is free moving for your comfort. It only locks when necessary. But when you want to maintain a firm seating position all of the time, there's a cinch button on each retractor to lock the lap belt in place.
I don't have to tell you that the Corvette is fun to drive. You already know that. But hopefully, like me, you've gained a greater appreciation for the commitment to the ongoing development behind Corvette and the passion that John and the others on the Corvette team feel for your car.
Drive it and enjoy it.
Corvette has long been recognized as one of the world's premier performance cars and as one of the automotive industry's design and technology pioneers. As Chief Engineer David Hill explains, the 1996 Corvette's evolution continues, keeping it at the forefront of automotive engineering.
Even though 96 is the 13th year of the 4th generation Corvette, we've actually got 4 important product achievements that are being introduced this year. First of all, there's that elegant collector edition car, which commemorates the conclusion of the C4 and is really an elegant car. Then we've got this Visceral Grand Sport, which is our highest performance car and reminds us that this Corvette especially, but all Corvettes, have a great linkage to our racing experience both in the past and our racing experience of today. Then we've got the 330 horsepower LT4, which is the climax of the Gen 2 small block V8 and represents the highest as installed power that we've ever had in a small block. And finally, the selective real-time damping brings state-of-the-art electronically augmented suspension, an actual active damping suspension ride, which offers a marvelous capability for grand touring and the best we've ever had in combination of ride and handling comfort. So 96 is a really significant year.
V8 power has long been the foundation of Corvette performance. It began in 1955 with Zora Duntov driving a V8 powered prototype Corvette to a new speed record in the Daytona measured mile, and continued in 1965 with the introduction of the big block V8. In 1970 with the original LT1, and in 1992 with the second generation LT1. 1996 will be remembered as the year of the LT4.
We used 3 main strategies in developing this program. The first was we had to go get the performance we promised the customer. We had to do that without compromising durability, and last but not least, we wanted the engine to look different. If it's a different motor, it ought to look different.
The key difference in the performance ratings between the LT4 and LT1 is horsepower. The LT4 generates 330 horsepower at 5,800 RPM, while the LT1 is rated at 300 horsepower at 5,000 RPM. Torque ratings for the two engines are both 340 foot-pounds. To increase the LT4's power, the engineering team concentrated on improving both engine airflow and engine speed capability.
In terms of airflow improvements, we start right with the intake manifold. The intake manifold ports have been made larger to enable more air to flow into the motor. That would be futile were we not in a position, and had we not opened up the intake port on the cylinder head. In fact, we opened up both the intake and the exhaust port on the cylinder head. The piston has been significantly modified in the eyebrow cut area to increase the compression ratio significantly, another historic and traditional performance improver. And last but not least, certainly each performance enthusiast would appreciate the aggressive camshaft that the LT4 features, giving us camshaft lifts back up in the half-inch range, a historic benchmark for the performance enthusiast. In terms of improving components of the engine to allow higher engine speed, those improvements were focused largely in the valve train area. First, beginning with the valve springs, they have been made higher load to assure us no valve flutter at the higher speeds. One of the other key strategies is to reduce valve train inertias, and we've accomplished that by actually going with hollow stem valves. Both the intake and exhaust valve are actually hollowed out in the stem area to reduce mass, and then subsequent to that, the exhaust valve stem is filled with sodium for purposes of heat transfer. The third and final area of improvement is a new technology for us as well, and that's demonstrated by the roller tip and axle rocker, again in an effort to reduce friction to allow us to spin the motor significantly faster.
The enhanced performance of the LT4 also required Corvette engineers to ensure the engine could stand up to the increased stress of higher RPMs and more horsepower.
The first of those is in the area of the torsional damper. Historically, we have used a single mass damper tuned at a specific engine speed to reduce torsional vibration. The LT4 employs a quote-unquote dual mass damper, which allows us two speeds, a low speed and a high speed, at which we can effectively tune out torsional vibrations. The second area of major improvement from a durability standpoint comes in our camshaft and water pump drive system. We have upgraded all the gears in that system to steel, and furthermore, we have changed the chain from a butt-link chain to the much more durable and racing-proven roller chain. The final area of durability improvement is in the crankshaft itself. The crankshaft material has not been changed. It is still cast iron. However, we now are employing an undercut and rolling of the fillets. Again, a strategy very common to the racer.
Finally, the LT4's appearance was also modified. Special red accents on the intake manifold and valve covers, along with red spark plug wires, all help distinguish the LT4. A special Grand Sport identification badge on top of the throttle body assembly on all LT4 engines is a gentle reminder that there's a little Grand Sport in every LT4 Corvette. For 1996, all Corvettes use a more sophisticated emissions diagnostic system called OBD2. OBD2 stands for Onboard Diagnostics, second generation. If OBD2 detects a problem, the service engine soon light will illuminate on your driver information center.
There are two modes that OBD2 can control the service engine soon light in. There's a steady on light, which indicates that a malfunction has been detected in an emission-related component or system, or a flashing service engine soon light, which indicates that a misfire has been detected in the engine. If the service engine soon light comes on solid, the owner should first go to the owner's manual and check out the various steps that are in there regarding checking fuel quality, making sure the vehicle is not running low on fuel, and making sure that you haven't recently driven through deep water, getting electrical components in the vehicle wet.
Your owner's manual provides instructions for correcting each of these situations. If the light remains on after 2 or 3 additional drive trips, the vehicle should be taken to your dealership for diagnosis and service.
If the service engine soon light starts flashing, it indicates that a misfire has been detected in the engine. A misfire can result in higher emissions and damage to emission-related components in the engine. If this situation occurs, there's a series of steps to follow in the owner's manual to reduce the load on the engine. That would be avoid climbing steep grades, slow the vehicle down, reduce the weight in the vehicle, and this should get the light from a flashing service engine soon light back to a steady on light. And then the vehicle should be taken into the dealership for service and repair.
Perhaps nothing showcases the ongoing evolution of Corvette better than the refinements and fine-tuning of its suspension system. For 1996, Corvette has set a new standard for ride and handling with the introduction of its available selective real-time damping system. Drivers can set the sensitivity of Corvette's selective real-time damping system using the rotary switch on the center console. Touring provides maximum road isolation and driving comfort. Sport dials the car in a little tighter for an enhanced performance feel. And Performance delivers Corvette's maximum handling capability.
The basic intent of applying real-time damping system to the 96 Corvette is to enhance the ride and handling bandwidth of the system. The way the RTD system functions, basically, I'll start off with the mechanization briefly, is there's 4 position sensors, one at each corner of the vehicle. Those basically measure wheel-to-body displacement information. There's 4 electronically controlled shock absorbers that have the ability in each corner to go from soft to firm levels of damping.
The sensors at each corner of the car are continually monitoring 2 major inputs, body velocity and wheel velocity, which is the up and down vertical motion of the wheel.
Now, once we have the body velocities, it even gets broken up into 3 modal terms from there: heave, pitch, and roll velocity. What I mean by heave, it's a phenomenon the car has where if you picture the car going over a railroad track swell, the car is going to be in phase, it finally settles out down the road, we call that a heave motion. The pitch motion is induced usually by hard braking, where you get the nose pitching down, or pitch up, which would be a hard acceleration, where the nose wants to lift up. The last one being roll is usually induced by steering inputs, where the driver is going to turn the car one way or the other and the vehicle will tend to roll. Vehicle speed is important from a control standpoint. As vehicle speed increases, you usually want more control out of the vehicle. So at higher vehicle speeds, the system will be more sensitive to wheel and body motions as it would be at lower speeds. Now, all those velocities, heave, pitch, roll, and wheel at each corner are compared very quickly to predetermined thresholds that are determined by ride development engineers at Corvette as far as how they want the Corvette to react and how sensitive they want the system to be. Once any of those velocities exceed those thresholds, so if heave, pitch, or roll, or wheel exceeds any one of those thresholds, the system automatically will command firm damping levels to the shock absorbers at the precise time and for the precise duration in order to dampen that vehicle out. Up here you can see the position sensor I've been mentioning, and basically it's a rotary potentiometer that puts out a 0 to 5 volt signal as this arm swings through its arc. The other part of the system here in the corner is the shock absorber, and it's hard to see, but there's an integral fast-acting solenoid valve attached to it.
The brain of this sophisticated system is a powerful electronic control module. It continually reads signals from the sensors and then controls the damping of each shock absorber through the fast-acting solenoids.
The function of the control module is to both monitor the sensors, take the data from the sensors, and then control the shock absorbers on a real-time basis to provide the desired ride of the vehicle down the road. What we have here is a dual processor control module. We have a microprocessor, a digital signal processor, and we have some electronics on here which control the shock absorbers. The algorithm in the microprocessor runs every 1 millisecond. It basically samples the sensor inputs coming from the position sensors of the wheels and then commands the shocks to the firm or soft state.
All of the technology that goes into selective real-time damping is focused on a single goal: to further enhance Corvette's ride quality without sacrificing its world-class handling characteristics. Tires are another important part of Corvette's suspension system and work in conjunction with shocks, springs, and stabilizer bars to give Corvette its performance edge. Corvette has always been an industry leader in tire design and technology. From the original unidirectional gaterbacks in 1984, the asymmetrical tread pattern of the Eagle GSCs introduced in 1992, and then the Goodyear Eagle GSC Extended Mobility Tires, EMTs, with run-flat capability that are again available for 1996.
The intent of the EMT was to design a tire that would be transparent to the user when inflated. It feels just like a normal Eagle GSC. The advantages only come into play when it loses air. But we don't want your Corvette to behave any differently on the EMT inflated than it does on a conventional GSC.
The Extended Mobility Tire is designed much like a conventional Eagle GSC, but it also utilizes specially compounded inserts that are built into the sidewall. These inserts are strong enough to support the weight of the vehicle in the event of air loss at speeds of up to 55 miles per hour for as far as 200 miles.
The first benefit of the EMT is the security of knowing that if you damage a tire to the point of air loss, you don't necessarily have to stop. You have a period of 200 miles in which to decide where you're going to stop and when you're going to stop.
The available extended mobility tires are teamed with Corvette's low tire pressure warning system. It utilizes tire pressure sensors at each wheel that are continually sending a low-frequency radio signal to a receiver. When the receiver detects a loss of tire pressure, the low flat tire light will illuminate on the driver information center. The technological evolution of Corvette is an ongoing quest for the ultimate performance car. The additions of new features like the LT4 V8 and selective real-time damping for 1996 not only help make Corvette a more exciting and enjoyable car to drive today, they also provide a glimpse into what the future may hold for America's legendary sports car. This program overviews the operation of key features on your Corvette and explains things you might notice that are a part of the car's normal operation. Your knowledge and understanding of Corvette will greatly enhance your ownership enjoyment. First, let's review Corvette's passive keyless entry, commonly referred to as PKE. It automatically unlocks the car and disarms the security system as you approach the vehicle. The system's range is approximately 5 feet. As you leave the vehicle, it automatically locks the doors and turns on the alarm. The horn also chirps to let you know that the car is locked and secure. In order to operate, the PKE system must first be programmed. In most cases, this will have been done at the dealership, and if your passive keyless entry is already operating, there's no need to program it at this time. If PKE is not operating, you must first learn if it's programmed but simply turned off. Here's how. Make sure the key is out of the ignition and the radio is off. Then press and hold the door button on the key fob for more than 2 seconds. If the system is programmed, the doors will lock and then unlock to tell you that it is now turned on. If nothing happens, you will need to program the system. Programming creates a unique computerized security code between the transmitter key fob and your car's PKE receiver. More than 1 million possible security code combinations exist, so there's very little chance of 2 cars having identical codes. There are 7 easy steps in programming PKE. First, move all transmitters to be programmed out of range of the vehicle. The approximate ranges for coupe and convertible models are shown in this diagram. Second, put the key in the ignition and turn it to the on position, but do not start the car. Third, push the trip auto button twice. And fourth, within 5 seconds, push and hold the fuel info button until the passive keyless entry light illuminates on the driver information center, or DIC. The 5th step is to turn the ignition off, but do not remove the key. You'll see the passive keyless entry light start flashing once per second. Step number 6 is to bring the first transmitter into range. Once the receiver recognizes it, the passive keyless entry light will illuminate solid. Please remember to only bring 1 transmitter into range at a time. Finally, take the transmitter out of range. The DIC light will then start flashing 2 times per second. If a second or third transmitter needs to be programmed, simply repeat steps 6 and 7. Once all transmitters are programmed, remove the key from the ignition. If you ever add an additional transmitter, you will need to reprogram your vehicle with all transmitters at the same time. You can also reprogram if you want to ensure programming security so no other transmitters will work. Once the system is programmed, you can easily turn it on and off and switch between modes. Turn it on and off as follows. First, bring the transmitter into range and make sure the key is out of the ignition. Second, press and hold the door button on the transmitter for more than 2 seconds. The doors will then lock and unlock. If the system was on, it's now off. And if it was off, it's now on. It's recommended to turn the system off if you take the keys and leave someone waiting in the car so they don't set off the alarm if they open the door, or if you'll be working in or around the car and moving in and out of the system's range. When the PKE is on, you can choose between two modes of operation. The first mode unlocks the driver's door as you approach the car, while the second mode unlocks both doors. Either locks both doors as you walk away from the car. To select the operating mode that's most convenient for you, follow these two steps. First, bring the transmitter into range and place the key in the ignition, but do not turn it on. Second, press and hold the door button on the transmitter fob for more than 2 seconds. When the system recognizes the transmitter, both doors will lock, and then either the driver's door or both doors will unlock. This tells you which mode the system is now in. For example, if only the driver's door unlocks, the system is on driver's door only mode. To activate the both doors mode, simply repeat this procedure by holding the door button for more than 2 seconds again. On coupe models, the key fob also serves as a remote for the passenger's door if your PKE system is in the driver's door only mode or if it is turned off. Simply press the door button to unlock the passenger side. It also has a button to operate the rear hatch. On Corvette convertible, the fob only has a door button for the passenger side. Finally, if the key is fully in the ignition, PKE prevents you from locking your keys in the car. Next, let's review Corvette's instrument cluster and controls. To the right of the digital speedometer, you'll see analog gauges that provide quick reference readouts for oil pressure, oil temperature, coolant temperature, and voltage. When you want exact digital readouts, use the Gauges button on the trip monitor to cycle through readings for oil temperature, coolant temperature, volts, and transmission fluid temperature. The trip monitor can provide you with an array of valuable readouts. Please refer to your owner's manual for a complete overview of trip monitor functions. You'll also notice that at the top of the trip monitor, there's a small electronic eye, which adjusts instrument panel readouts for the best visibility. All Corvettes are also equipped with a standard engine oil life monitor. It measures engine temperature and revolutions to calculate the approximate life expectancy of your motor oil. The change oil light will illuminate next to the tachometer to signal the need for an oil change. When the oil is changed, reset the oil life monitor as follows. Turn the ignition to the on position, but do not start the car. Then press the English metric button on the trip monitor. Within 5 seconds, press the English metric button a second time. Within 5 seconds of that, press the Gauges button and hold it in. The change oil light will begin flashing. Keep the Gauges button pressed until the change oil light stops flashing and goes out. This takes about 10 seconds. The oil life monitor is now reset. Please remember, however, this feature only serves as a reminder of the need for service. Always change your oil as recommended in the owner's manual, even if the change oil light has not yet come on. And you must reset the oil life monitor each time you change the oil. Please also remember that your car's engine is factory filled with synthetic motor oil, and it is recommended for all oil changes. Located next to the trip monitor is the Driver Information Center. Your owner's manual has complete descriptions of what all the DIC lights mean and what you should do if they signal a need for service to one of the systems. Corvette's acceleration slip regulation traction control system is automatically turned on each time you start the car. You'll know the times when ASR is functioning by the feedback you feel in the accelerator pedal and the ASR active light on the DIC. ASR might also activate briefly if you drive over a railroad crossing or other bumpy surface. When ASR activates, cruise control is automatically disengaged and must be manually reset. The on-off switch for ASR is located on the left-hand side of the instrument panel, just above the light control. When you turn it off, the ASR off light illuminates on the DIC. And if the system needs to be checked, the service ASR light will illuminate. Features that all Corvette sound systems share on their cassette players, as well as the CD player on the Gold Series system, include a search button that advances to the next selection, a repeat button that automatically replays the previous selection, and a scan function that plays the first 8 seconds of each selection. When the tape or CD reaches the piece you want to hear, simply push the scan button again. The search and scan buttons work for the cassette and CD players only. To search for the next radio station, simply press the auto button and then either the up or down arrow on the tune button. The radio will automatically stop at the next station. Setting the clock is a simple procedure. First, push the set button. The indicator light will glow for 5 seconds. Then use the tune down arrow to set the hour and the tune up arrow to set the minutes. Corvette convenience features include an express down driver's window that's operated by pressing the power window switch in the down direction and then releasing it. And a delayed accessory bus that allows you to operate the sound system and windows for several minutes after the car has been turned off or until a door is opened. There's also a turn signal reminder chime if the indicator has been left on for more than 1 mile of driving. Finally, Corvette's parking brake, which is located to the left of the driver's seat, operates as follows. To engage the parking brake, depress the brake pedal and pull up on the parking brake lever. Then lower the lever to its original position. To release the parking brake, depress the brake pedal and pull up on the parking brake lever until you can push in the release button. Then, holding the release button in, lower the lever. Corvette is an exciting car to own and drive. Your ability to operate its features to their fullest potential can greatly increase your enjoyment of your Corvette. A Corvette kept in good condition is destined to become a collector's item. That's one reason why many Corvette owners impeccably maintain their cars. A more common reason, though, is that Corvette owners simply have a lot of fun keeping their cars looking good and running well. There are many things you can do to your new Corvette that will preserve its great looks over time. When washing your Corvette, use only mild liquid hand soap or specially formulated car washes. Do not wash your Corvette in direct sunlight, and avoid using dishwashing soap or stronger cleansers, which can be abrasive to the car's base coat clear coat paint finish. Begin by wetting down the car to remove any excess dirt and debris. Then wash the car in sections with a soft, non-abrasive cotton cloth. Rinse the car off thoroughly soon after applying the soapy wash water. And then dry it with a clean, soft chamois. If you own a convertible, be sure to clean the top often. Use a mild soap in lukewarm water. Harsh cleansers could damage or discolor the fabric. Clean one area of the roof surface at a time with a soft bristled brush, supporting that section underneath with your other hand. Then rinse the roof thoroughly, removing all soap from the fabric. Be sure to let it dry completely before lowering it. A damp top can wrinkle, and trapped water can cause stains or mildew. Also remember not to adhere any objects, such as temporary license tabs or stickers, to the glass backlight, because they might damage the defogger grid when removed. And if you use an automatic car wash, be sure to turn off your radio to lower the antenna. Corvette's aluminum wheels have been treated with a protective coating that resists mars and scratches. Clean the wheels with mild soap and a soft bristled brush. Do not use strong cleansers, stiff bristled brushes, or any type of chrome polish. If you choose to use a rubber protectant on your tires, first make sure the tires are dry, and then apply the protectant to a sponge or cloth first, and wipe the tires, avoiding contact with the wheels. In order to allow ample time for the new paint surface to fully cure, do not wax your Corvette for the first 60 days. When you do wax, use only non-abrasive products that are approved for base coat clear coat paint finishes. By masking off the porous surfaces of the door handles, You can ensure that they remain free of any excess wax, which can be difficult to remove. Apply the wax with light circular motions. Forcing the wax into the finish will often dull it or leave swirl marks. If you plan to use a power buffer, only oscillating types are recommended. Once you've finished waxing your Corvette, use a detailing brush to remove any excess polish around emblems, trim, seams, and parking lamps. The seats, door panels, center console, and top of the instrument panel can be easily cleaned with mild soap and warm water. Parking your Corvette coupe on a level surface makes the removal and replacement of the roof panel quick and easy. A ratchet is housed in the center console to remove bolts, which are located behind the front sun visors and along the back of the roof panel. When stowing the panel, keep it top up and make sure it fits securely into the brackets on each side of the rear stowage compartment. Then push forward and carefully lower the front edge into the safety latch. In order to prevent damage to the weather strip, always close the rear hatch glass from directly above the striker assembly, located in the center along the edge of the glass. Now you're ready for Corvette Coupe's unique open-air ride and feel. When taking the top down on convertible models, first lower the windows. Then loosen the Velcro strips at the rear of each side window opening and release the two front latches. Next, pull the release handle that's on the underside of the parcel shelf behind the driver's seat. Then lift up on the back of the roof and push the lid release button next to the handle. Then open the lid. There's also a lid release button in the center console. The top folds down easily. Remember to return the front latches to their closed positions once the top is lowered. And the compartment cover is fully integrated into the car's body. New for 1996, your Corvette's cooling system is filled with orange-colored DexCool engine coolant. This coolant is designed to remain in your vehicle for 5 years or 100,000 miles, whichever comes first. When adding coolant, it is important that you use DexCool silicate-free coolant. If traditional silicated coolant is added to the system, premature engine, heater core, or radiator corrosion may result. In addition, the engine coolant will require change sooner, at 24 months or 30,000 miles, whichever comes first. See your owner's manual for additional information on DexCool. Corvette's engine compartment has all fluid level checkpoints, clearly labeled for easy identification. By checking your fluid levels regularly, you can ensure that your Corvette is always in top running condition. If you clean engine components, do so with only a wet cloth. Do not use alkaline-based cleansers. They can discolor aluminum. When closing the hood, simply line up the upper and lower portions of the strut and release the hood from a height of about 20 inches above the cowl. Then check to make sure it latched securely. You should also check the tire pressure of your Corvette's Goodyear Eagle GSC tires often. Because of the tire's low-profile design, it can be difficult to detect underinflation just by looking at them. Check the pressure of all 4 tires if the available low tire pressure warning system illuminates the low tire pressure light on the Driver Information Center display. Because of the GSC's asymmetrical tread pattern, plus the fact that the rear wheels and tires are wider than those on the front of most Corvette models, the tires cannot be rotated. Should you need to change a tire unexpectedly, the jack is located in the storage compartment behind the passenger seat. And there's a socket designed specifically to remove the wheel lug nuts, along with a lug nut key. Remember to provide both to the technician who services your vehicle. The lug wrench is secured to the floor behind the driver's seat. Corvette's jacking points are shown in this diagram. Because Corvette is a high-performance machine, you're encouraged to have routine maintenance and service performed by your Chevrolet dealer. Chevrolet technicians undergo special training that enables them to expertly service your Corvette. Chevrolet Corvette. Throughout automotive history, the name has been synonymous with performance and sophistication. that add up to the highest level of driving enthusiasm anywhere. By properly caring for your new Corvette, you're helping preserve the legend of the true American sports car.
More than 3,500 components from the top suppliers worldwide converge in Bowling Green, Kentucky, where dedicated employees ply their trades. In a building that covers 1 million square feet and contains more than 7 miles of conveyors. These are the elements that work together to produce the Corvette, the world's premier sports car. The pride of Chevrolet comes together on the line at the Corvette assembly plant in Bowling Green, the only plant in the world charged with producing America's dream car. The building of Corvette is a deliberate, almost painstaking process. Each vehicle takes more than 5 days to build, and quality is foremost at every point along the assembly line. That quality begins with Corvette's rigid uniframe construction. 53 robotic welders produce its strong skeleton, applying more than 1,200 spot welds in a matter of minutes. Another 120 inches of precision welds are carefully done by hand. The uniframe acts as a steel cage, which provides structural integrity and contributes greatly to the vehicle's overall safety. The result is one of the world's most structurally sound sports cars. Belying the strength of the steel uniframe is another of Corvette's trademarks, its sleek fiberglass body. Before the fiberglass panels are installed, they're wiped with a special solvent that unmasks any hidden defects on the surface. The panels are then attached to the uniframe with adhesives applied by hand. The actual bonding is done by machine to ensure precise adhesion. 10 major panels are joined to the uniframe, including rocker panels, the deck lid and halo, and the hood. Many of Corvette's body panels are lightweight fiberglass, allowing the coupe to maintain its trim curb weight of approximately 3,300 pounds. To ensure that the body panel assembly meets rigid design specifications, point check inspections are conducted regularly throughout the day. During these inspections, technicians use highly specialized instruments, checking body panels to guarantee that fit and alignment are exact on 3 different planes. Once the body is assembled and inspected for quality, the painting process begins. First, the body is prepared to provide a smooth surface. Painting is done with a combination of robotic and hand spraying, and each vehicle receives 6 coats of finish, 2 coats of primer, 2 coats of enamel base coat or color coat, and 2 coats of clear coat. The entire process takes approximately 14 hours per vehicle and culminates in a detailed inspection of every car. While its lustrous and durable body is assembled, the core of Corvette performance is simultaneously coming together. The car's chassis, drivetrain, and suspension are assembled at various points along the line. The independent rear suspension features a 5-link design, a glass epoxy monoleaf spring, limited slip differential, and many aluminum components. Like the rear suspension, the front suspension is also independent, utilizes many lightweight aluminum components and a monoleaf spring. It also features a tubular steel stabilizer bar. Once the front and rear sub-assemblies are complete, they're each joined to the engine and then the drive shaft. Corvette's slick body and sturdy chassis are then married, quite literally in fact, to form a nearly complete vehicle. At the marriage area, the body slowly drops down from above to be mated with the chassis. The two are joined at 14 separate contact points to assure a perfect match. Wheels and tires are also married, so to speak, at another location within the plant. Corvette's Goodyear GSC asymmetrical tires are teamed with directional 17-inch aluminum wheels and then perfectly mounted and balanced. First, there's the uniformity machine, which simulates the tire on the road, checking for tire integrity to avoid future and unwanted vibrations. The Bowling Green plant is unique in that it checks 100% of its tires for uniformity. Next is the dynamic balance, which determines exactly how much weight should be added to the inner and outer flanges of the wheel and precisely where the weight should be placed. And finally, the static balance, where the weights are double-checked to within 1/4 ounce of accuracy. Once the wheels are ideally balanced, they're ready to be mounted on the vehicles. At the startup area, gasoline is added to the tank, the fuel pump is turned on, the system is primed, and each Corvette is fired up for the first time. Now the car is ready to roll. The end of the assembly line marks the first time Corvette's tires touch the ground. Vehicles are driven off the line and over a series of speed bumps to help settle the front and rear suspensions. All four wheels are precisely aligned, contributing to Corvette's responsive handling. Then, because Corvette owners demand perfection, the vehicles undergo an extensive battery of quality checks and performance tests. There's the sonic test that checks critical seals to see if sound escapes from the passenger compartment. The water test, which douses the car from several angles to check for possible leaks. And the dynamometer, to ensure engines are functioning correctly and to measure their emission levels. All this is done to provide Corvette buyers with an ownership experience unmatched by lesser vehicles.
Corvette Action Center, Jerry.
Part of that experience includes customer assistance at the factory. Enter the Corvette Action Center.
Models, there's a feature that allows you to operate your power windows or your radio for up to 15 minutes after the
Located in the plant, the Action Center answers approximately 150 product-related questions per day. Of course, your local Chevrolet dealer should always be your first source of expertise. However, if your dealer is unable to answer your question, you can reach the Corvette Action Center at area code 502-745-8101 or 1-800-457-VETT. Structural integrity, remarkable power, ultra-high quality, seductively attractive. The world's most distinguished sports car, built for the world's most discerning buyers. ongoing testing and evaluation are hallmarks of the commitment to quality behind Corvette. Throughout the year, cars are continually being scrutinized by engineers, plant personnel, and other members of the Corvette team to help ensure customer satisfaction and enthusiasm.
How many guys haven't been on one of these drive audits before? Okay. We won't go through a lot of stuff today because I expected most of you would be familiar with what we're doing here. The pattern we're following is pretty much identical to what we've done for about the last 2 years.
You want to read this and do the lighting checks?
In this week-long activity that takes place early in the year before the first production vehicle is built, engineering groups are taking 10 pilot vehicles that come off the Bowling Green assembly line for extensive audit drives. During the drives, each Corvette undergoes a thorough evaluation. Everything from engine performance and handling to top removal and tire changing, all to help ensure the production cars are right when they begin rolling off the line for customers.
Pilot is a pre-production vehicle. You're proving out the process, you're proving out the parts to make sure that they're all correct.
The 250-mile trip leaves the plant at 7 a.m. and begins crisscrossing the Kentucky countryside.
Try to encompass as many driving situations as we can. We start off on the expressway. We go through several little towns, so we get in some traffic. We deteriorate in road quality as the day goes along and end up in fairly secondary types of roads. There's some of the route is relatively flat, and then there's some hills and curves and a lot of variation in the type of road.
At pre-planned stops along the route, team members have the opportunity to perform their assigned tasks, discuss items they've noticed while driving, and compare notes. Many times, the audit drive is the first time new systems and components can be evaluated on cars that were assembled under regular plant production conditions. This gives engineers a preview of what will really happen when regular production begins.
Well, we spent the last year working real hard on fits and finishes, and this is a final buy-off to make sure that we have all our fits and finishes in line and that it'll meet customer expectations.
But it's not just the new components that receive careful examination.
We're going to do a steering evaluation, lock to lock, we'll be doing on that portion of the blacktop. And what we do is we're going to turn the wheel to lock on one side, and we're listening for steering moans, interferences, tire interferences, then we'll turn the other way, so it's like a figure eight.
The audit drives are purposely designed so Corvette team members can experience and evaluate the vehicles in real-world situations through the customer's eyes. Other tests conducted on this pre-production shakedown trip included making sure the anti-theft alarm was in working order, testing the passive keyless entry system to ensure it's working properly, and even tuning in radio stations to make sure that reception is clear. The team's pride in Corvette and commitment to customer satisfaction is clearly evident in its attention to detail and concern for quality.
When I first started in the Corvette group in '75, I was driving cars myself, by myself, all day long, and that was the audit drive.
Times have changed. The annual pre-production pilot audit drives are just one small part of the constant evaluation and testing of Corvette. Longer-term 3- and 10,000-mile durability tests, endurance runs, and cross-country trip evaluations, as well as a battery of proving ground testing, are all part of the ongoing Corvette quality story.
The difference is we're going to get a downhill and an uphill check on the parking brake.
And while it's a relentless pursuit, it doesn't mean that the team can't take time out along the way to help a motorist in distress.
How many engineers does it take to change a tire?
Then it's back to the task at hand. What's learned on this trip will be another valuable step toward ensuring the highest standards of production quality. When arriving back at the Bowling Green plant, the final stop for many of the cars is the Rumble Road.
It's a bumped road, and what they've done is they've made it like corrugated cardboard.
Okay, let's resolve those before we go into the details then.
At the end of the day, the team holds a several-hour debriefing to review all findings. Action plans are then developed to help ensure final production quality.
And the intent is to have a plan of action on every item before we go home. If we have a major problem, we'll either get a solution or we'll delay production.
We want to make sure that they're going to get a completely qualified vehicle, a quality car, something that's going to make us proud and make them proud.
And that's the bottom line. An uncompromising commitment to quality, measured in both established procedures and systems, and in the caring and dedication of people.